Technology, it's working. Good morning, and thank you for giving me the opportunity to speak here. My name's Greenshields. I have to stand still. I'm used to walking around. We're in an academic area, so I shall stand behind the podium and speak properly. My name's Ian Greenshields. I'm an applications engineer with EBV Elektronik. EBV is a distributor of electronic components. And we've talked and we've heard a lot this morning about the IOT, the Internet of Things. As an engineer, I always have a little bit of a problem with nebulous marketing terms. And as an industry, I think we've come up with rather a bad name, the Internet of Things. The Internet, I think everyone understands, and we know what that is. We use it every day. But what is a thing? What do we mean by a thing? And why are there going to be so many of them? And more importantly, if we can define what a thing is, how do we then connect it to the internet? And that's where it comes down to the component level products. So what I want to do is to demystify what we mean by a thing within the Internet of Things. And I think it's quite important because we work in an industry which hopefully we want to make some money from. Now, you can't sell hype and ideas, you have to sell product. And if we want to be a good manufacturing industry, we have to sell hardware. So what I want to do is just show practically what it means to have something connected to the internet, and we used the Sigfox as a very good example of that, and what the Internet of Things actually means. So there's been quite a lot of slides already, I think, on the ecosystem of what it looks like, but essentially we have the cloud, that's another nebulous word, but that, to me, is the internet. We have the internet, and we want to connect something to the internet. So the thing, to me, is actually, it's not a thing at all. It's very simple. It's a sensor. And it's a sensor that we need to connect wirelessly to the internet. So what we care about is, what is that sensor, and how do we connect it to the internet? And then I think we take some of the, we can remove the word thing from the Internet of Things. To me, it's a wirelessly connected sensor. So right out here, we've got a sensor, and we need to connect it back to the internet. If I look around me in this room, if you look up there, you can see there's smoke detectors, there's probably temperature sensors, there'll be, there's probably some light detectors or something. These are all sensors. And they're probably all connected via wires today because that's how it works. To wire things up now is actually quite expensive. To do it wirelessly is a lot cheaper. So we're going to start seeing an awful lot of sensors connected wirelessly to the internet. And that's really what it means by a thing. So I'm an RF engineer, and as soon as I hear the word wireless, that means RF, that means radios. We need radio, we need a transmitter, we need a receiver, we may need one of each on each end. But we're basically talking about wireless or radio communication to the sensor. So one of the problems of using radio communications is you have regulatory problems to deal with. You can connect to two telephones with a bit of wire and no one cares. As soon as you transmit a signal out, someone, somewhere, is going to say, oh, hang on a minute, we can make some money out of that. You need a license to do this. And fortunately, there are some frequency bands. Frequency is a little bit like real estate. I guess it's a little bit like real estate for startups in Dublin now. There are some very attractive parts of the frequency spectrum, and there's some nasty neighborhoods where you don't really want to be. Well, the attractive parts of the spectrum are the ones that are all sold off to the cellular operators for billions of pounds, and the government's all raised a lot of money out of it. The nasty neighborhoods is the cheap spectrum, where you have bad neighbors such as microwave ovens and industrial, scientific, medical, high-power applications. But these bands or these frequencies have all been given, we're allowed to use them for free. You don't have to buy a license to use your Wi-Fi network at home. There are certain frequencies that we can use globally. Now, the Sigfox network, and indeed a lot of the wireless networks which are used by our internet-connected sensors, use the license-free bands. So it makes it an awful lot cheaper, in as much as we don't have to... one of the reasons the cellular prices are so expensive is the cellular operators have got to recover all those billions of euros they paid for that frequency space. With a network like Sigfox, we're using the license-free bands, and it's very, very low data rate, so it doesn't use very much spectrum. And it's basically, we can use that for free. It brings the costs right down. Almost everywhere in the world now has access to certain frequencies, license-free bands, also known as short-range devices or industrial, scientific, medical. And as we saw in the last presentation now, there are frequency bands that can be used to provide global coverage on a very low-cost, low-power basis. And that's what the Sigfox network is using. It's using the license-free bands at 868 megahertz and 915 megahertz in the US. Across most of Europe, it uses 868 megahertz, and I'm wearing a Sigfox sensor hanging around my neck at the moment, which is measuring the temperature. And this is transmitting at 868 megahertz to a base station, probably not that one, I don't know if it's powered up, but some that could be tens of kilometers away. So I've got a radio in here, which is transmitting and receiving over a distance of as much as several tens of kilometers, maybe a little bit less because I'm inside a building here. And something like this can run off a coin cell for years and years. Try doing that with your smartphone. It won't run off a coin cell, and if it did, it would run for a minute or two. That's the difference. Now, you can't stream video on this either, so it's a low data rate, very low power, and we're using the license-free ISM bands, or the global frequency bands that are allowed for that. So, in terms of actual hardware then, what do we need? If you've got an idea for a product and think, yes, okay, I've got a sensor, how do I get the signal? What hardware is needed to do that? As a distributor, we work now with a number of suppliers who are really investing a lot in products for Sigfox. And as I mentioned, anything that your thing within the internet is basically a sensor that's got wireless connectivity to it. So what we're looking at here is the actual wireless or the radio part of that sensor. This is what you need to connect your sensor to the internet wirelessly. So there will be, in this example here, I'm looking at a product from Analog Devices. Analog Devices is one of our key suppliers, a very large semiconductor company based out of the US, and also have a very large facility in Limerick. And Analog Devices have Sigfox products now. If you've seen electronic printed circuit boards before, what you're looking at here, this is a low power MCU, a microprocessor or microcontroller, and this is a radio transceiver, so it's a transmitter and a receiver, and it's in a single IC, a single integrated circuit, just a couple of millimeters square. That contains everything that will let you send and receive the signal to the Sigfox base station and back again. Sigfox have openly published the specification, so anyone can use it. They have a qualification program which the semiconductor manufacturers are following to make sure that their products are Sigfox compliant. What that means is if you take a product which is Sigfox compliant, you can build it into your product and know it will work, know it will be accepted by the Sigfox community and will be allowed onto the network. And it's a very simple, low-cost way of doing it. So in terms of some of the key things, it's a radio, so what we care about is, well, how much power does it transmit and how good is the receiver? We call that, what that means in simple terms is, what is the range of the device? The Bluetooth part on my smartphone will go maybe 10 meters. That's not a lot of use if we're going outside or we want to track things. Something like this is sensitive enough and powerful enough that it will go many tens of kilometers. But at the same time, it has a current consumption or a sleep current of down into the nanoamps, and that's where you can get the multi-year battery life from a coin cell. So it's a very clever system, very sensitive radio link, very low power, very low data rate. It's only intended to send a few bytes of data at a time, and this is where the real power saving comes from. Another example, which you can actually see on our stand outside if you go out to the EBV stand, this is from Atmel. Atmel is another semiconductor manufacturer, global semiconductor manufacturer. And this is a little demo that shows Atmel's solution to put a Sigfox compliant radio inside your product. This is the device. It's very simple. It's a very simple I think it's 4x4 millimeter package of the transceiver. And that contains everything that will let you connect your sensor to the Sigfox network and the internet. It contains a radio, it contains a little bit of digital signal processing, it contains a microcontroller. Some of the technical specs are here, but again, what we're looking at is what sort of range can we work over and how much current does it need to do that? And that's the key, those are the key specs that we need to talk about. On Semiconductor is another semiconductor manufacturer doing a lot of development and bringing out products for the Sigfox market. In addition to just a simple semiconductor, there are complete products, complete modules that you can use to connect your product to the Sigfox network, even down to a USB stick. So you can just buy a USB dongle that would plug into a computer, and then you've got access to the Sigfox network. So anything from a simple IC component to a complete module. You don't need any. I'll move on to another one from Texas Instruments. And again, same type of idea. Texas Instruments does a lot of wireless connectivity solutions within your phones or your Bluetooth in the car. You'll have these kinds of products. For Sigfox, there are specific transceivers, IC transceivers, and modules that can be used in your products to connect them to the Sigfox network. One of the other key considerations, we're basically talking about a radio, and I guess a great many of us have been making phone calls, and then you get the usual, uh-oh, the signal's breaking up. Hang on a minute, let me move, let me try a different position. Yep, okay, I can hear you now. That is a problem of the antenna. The iPhone had a famous problem, I think, on the 4G, but the antenna is really important as well. The larger the antenna, the longer the range. We're looking for range. If you bury a tiny little antenna deep inside an electronic circuit, it will work, but the range will be much less. So in some of the design ideas or some of the design goals is how much space do I have? If you've got a people tracker, this has got a pretty small antenna in it. But if I was looking, I saw a couple of slides on showing a tree and a fire detector. If you can put a decent-sized antenna on it, it will increase the range by 10 kilometers or more. It's really significant. Some antennas, though, if the main priority is just to have a very, very small wristband, like a people tracker, you can print the antenna down onto the printed circuit board. You can get little chip antennas, which are really just a few millimeters. You pay for it a little bit in terms of range, but you can make very small solutions over a shorter range, or longer, or slightly larger solutions, which will give you much more of a range. Also, depending on the design skills, if you're designing a product, you can use the integrated circuits themselves and design around them. This is the cheaper way of doing it, but it involves quite a lot of electronic design in it. It involves RF skills in designing the radio, designing the antenna. If you just want to very simply put a product, a Sigfox or a transceiver in your product, you can buy pre-certified modules. So all you have to do is to solder the module down. It might even have an integrated antenna. Solder it down. You talk to it via a serial port or a parallel port, and it works. You need no RF or radio design skills at all. So there are both module solutions available and what we call chipset solutions available, or integrated circuit solutions. And again, we've got a number of them. If you're interested, we're displaying a few of them outside. Thank you. So the commercial time, as EBV Elektronik, we sell components from a great many semiconductor manufacturers. Won't go through them all, but that's these are the products, the suppliers that we carry, and we'll be very happy to talk to any of you in the outside afterwards. So just a very brief summary then of how we actually connect our sensor to the internet, and just a quick overview of the types of components and solutions that are available to let you do that. Okay, thank you very much.
That's Ian Greenshields, whose dad invented Greenshields stamps, I think, did he? We are now going to take a quick coffee break, after which we will be coming back to some further insights. One thing to remind you, Twitter, you are trending on Twitter at the moment, #NewFrontiers, and do put in the GMIT hubs, at GMIT hubs as well. Thank you. 15 minutes.